probably, if you'd done this individually, probably would have taken you about 30 minutes. It's a long assignment. I just had to figure it out with the page. But it was hard work, wasn't it? Long time, horrible. But with all the answers up here, y'all are starting to go, wait a minute. I can do this a lot faster. Right? What is your, I heard a few of you say it. What do you think is happening?
Take the exponent multiplied by the leading coefficient. And the power or whatever goes to.
Okay, so take the exponent, multiply it in front, and reduce the power by 1. But where did the 2 go?
It doesn't count.
Okay, let's just play it out. If it did have an x beside it, what would the exponent be?
1.
0, because what's anything in 0 power? Anything in 0 power 1? What's 0 times 2? It works. Sure. We can think about it. Yeah, you got the card. But if you think about it, it works, doesn't it? It also makes sense from yesterday that the derivative of a constant would be 0, doesn't it? Doesn't that make sense? The derivative of a constant, the slope of the constant would be 0. Okay, the next one looks pretty good, doesn't it? You reduce, what happens if you reduce the power of 1 by 1? You get a power of 0, okay, you get the 0 power of 1, so there's no x there, that makes sense. But the next one we're going to have to do the long way, because it didn't work, did it? What is the exponent on 1 over x? Ooh. So negative 1. Bring the negative 1 in front. What's negative 1 minus 1?
Negative 2.
Ooh. Negative 1 over x squared. I think it worked. Maybe it was a fluke. Okay, let's look at the next one.
Probably a fluke. Let's just keep it.
Yeah, that's always good. 3x squared on the next one. Worked. What about the next one? Did it work?
Yes.
What is this if I write it just as a x to a power? Negative 2x, and what's negative 2 minus 1? Maybe not a fluke.
It's coincidence.
Now see how long did that problem take you? How long did it take us just now? With a little bit of proper
4
seconds.
seconds.
Interesting. 2x cubed. Y'all didn't have to do that, but if you did, wouldn't it have taken you a long time? X plus h times x plus h times x plus h. It all times 2. Yeah, right. But the next one's surely not going to work. What is an exponent on a square root? 1/2. Well, let's try it. If this is x to the 1/2 power, I bring a 1/2 in front. Right? And what would the new power be? Negative 1/2. You work that one? There was an extra 2 in that.
Wait, so it's just half x and then negative half, so that means it's just 1 over.
You see where the 2 came from? Inward.
So this still works if you had like a full equation like that, x squared plus 2x, plus.
Yeah, there's the 5x squared minus 3x.
Or if this number after that.
Then that would be 0, so yes, you do.
So any number at the end, it doesn't.
The derivative is 0. Sorry. That one, same, very same. It's 2 times x to the 1/2 power, right? So 1/2 times the 2 is 1, x to the negative 1/2. Works great. Yuck, right? How long was it? It was pretty awful, wasn't it?
Well, she cheated.
it and it didn't work. There's a reason I gave y'all that one. Okay, but does it work? When the square root of x is x to the negative 1/2, right? Well, 1 over x. So this is x to the negative 1/2, right? That looks easy to me. Negative 1/2 x to the, what's 1/2? Negative 1/2 minus 1. Negative 1 and a half. Now you had the 3 that you mixed up. Does everyone agree? Well, is that the same as that? Isn't this a power of 1 and that's a power of a half? You add exponents. So 1 and a half would be 3/2. Now this is the answer you would get if you did it the long way. It looked more like this.
That's right. Get the 2.
This one.
So that's the answer if you did it this way.
Yeah.
You don't have to make it out like that.
But you get if you want it. So you just figured out what's called the power.
Did you make this up or did you?
No. I imagine Isaac Newton figured it out. He's a pretty smart dude. He works with derivatives enough. He probably figured it out. And when we get into velocity, position, acceleration, you'll kind of see how it makes sense. So if n is a rational number, meaning a fraction or something that can be made into a fraction, then the function f of x equals x to the n is differentiable, always. So if you have it, well, not maybe at any point, but it is, you can take the derivative of it. It may not be differentiable at 0 sometimes. We'll talk about that later. Yeah. And the derivative of x to the n is n x to the n minus 1. So let me show you what. Show you what we have included. We have a bell ringer. Every table did a derivative the long way. And this is what happened. The derivative of this was 2x. The derivative of this was 10x minus 3. The derivative of this, which we had kind of thought, oh, maybe it's the power in front reduces the power by 1. So we think maybe that works. Well, it's really not just right. Well, we tried it, x to the negative 1, negative 1x to the negative 2, it actually works. So this is the rule. You will probably want to go back and watch the video of the discovery. Okay, so the derivative of x to the n is n x to the n minus 1. A couple of other things you need to know. You don't have to write all of this. You probably already figured it out. If you have, because that rule only was just for x to the nth power, right? Well, what do you do if there's a constant sitting in front? Well, you already figured that out, right? You don't count by the constant. And that's what this rule says. It's called the constant multiple rule. If there's a constant in front of a function, you can just take the derivative of the function and multiply by the constant. The constant doesn't affect that derivative. That is not the same as two functions multiplied together. We'll have to talk about that on another day. Similarly, this kind of answers Kelsey's question earlier. If you have two functions added together, you can just take the derivative of each piece. Which you saw that's what we were doing on the bell ringer. Okay, we just took the derivative of each piece and added them up. Same thing with subtraction. What you will notice that is glaringly missing is multiplication and division. Those don't work quite so nicely. We'll have to talk about those on another day. So we don't have a rule for everything yet. We mainly have a rule for polynomials, which is a big deal. but we have a few more things left to get rules for. So you have a derivative of two. If you have two functions added together, you can just take the derivative of each piece. Again, you figured that out already, but we probably should say. So, see all of these derivatives? How long would have that taken you 10 minutes ago? Maybe a couple of days. Especially if you look down and notice how yucky stuff is. Maybe you couldn't even do it the other way. I better go through. Okay, you ready? What's the derivative of 5? Why? Right. Slope of 5 is 0. Right. That's okay if that's the way you think of it. But if you do choose to use the power rule, it doesn't work. It's probably overcomplicating it. The derivative of negative 507. Okay. Any constant, the derivative is 0. The derivative of a linear function, negative 5x. The derivative of 201x plus 400. So the derivative of any linear function, of course, is the slope. We actually had figured that rule out yesterday. 2 days ago, maybe. The derivative of a polynomial, 3x squared minus 4x. Wow, right? I told you I would like it.
It kind of makes you mad that you guys do these.
Yeah. But you would appreciate this. And you would understand where it came from.
So why is it a derivative?
The 2 to the power, you bring it down, right?
Oh, that's squared.
We have taken page-long problems and just made them 6-figure problems, right? This one you probably can't read. It's x to the 2/3 power. X to the 2/3 power. You don't have to write that a little better than you can see it. X to the 2/3 power. So what would the derivative be? 2/3. Bring the power in front. And then what do you do to the power? Subtract 1. What is 2/3 minus 1? That would have been almost impossible, wouldn't it? A cube root? Yeah. We just have to. Sure. If you did want to rewrite it, it would just be a cube root on the bottom. Should be 2 over 3. So this is the original was 2/3?
Yeah, I got it right, but it's not.
2/3 minus 1. Always subtract 1. What is the power on the square root of x? So I would rewrite this as x to the 1/2. So you will have to do some rewriting sometimes. That is all child's play compared to doing it the long way, right? Now a little property of exponents here and there, not a big deal. X to the 1/2 power, what's the derivative? And if you did want to rewrite that, that would be 1 over 2 square roots of x. And sometimes we will need to. Today we're focused on finding. Oh no, I can't do that using power rule. There's division in it, which is not the rule I know. By the way, that says the cube root of x over x squared plus 5 over x cubed. The cube root of x squared, or the cube root of x over x squared plus 5 rule for that? What could I do? You could, I
think first, if it's plus 5, 5 is 0, so the number that
no, with x cubed at the bottom. Because I've got a bottom, I can't have a bottom.
Get rid of the bottom.
I like that idea. Let's do simplify each piece. Let's start with 5 over x cubed because it's easier. What could I write 5 over x cubed as?
5x.
Would you agree that 5 over x cubed is the same as 5x to the negative third? Okay. Nice trick to play, right? Because now I can, on that piece, I already know the answer. It's negative 15x to the negative 4. Just subtract, make sure you subtract it. So that piece is good. What about the cube root of x over x squared? First of all, what's a cube root? A 1/3 power. So this top is x to the 1/3 power. Can you combine things using some property of exponents or reviewing some pre-cal?
Times by negative 2.
Okay. So 1/3 plus negative 2, thinking away Grant's doing, or 1/3 minus 2. You subtract exponents, you divide, you subtract. Y'all remember that? It's been a while, I know. But if I do that, what is 1/3 minus 2? It might take me a second, but 1/3. Almost negative 5/3. Negative 5/3. Negative 5/3. Now, it took a little work to get there, and I'm not lessening the amount. I know that took a little bit of work to get there. But now what's the derivative? With a little bit of pre-cal work. Why negative 8? Negative 5/3 minus 1, which minus 1 would be like minus 3/3. You get a common denominator. You do have to do that. Minus 15x to the negative 4th. Now, Grant already said, why did you make us do the long way? Well, there's a temptation in that problem to go, that was a hard problem, Miss King. Think about what you would have had to do without the power. The cube root of x plus h divided by x plus h squared plus 5 over x plus h cubed. Yeah, right? We're going to learn power rules. We're going to learn our properties of exponents and use power, right? In comparison to what we would have had to do yesterday. That's not too good. In fact, I don't even know if we could successfully get through it, right? That would be, I don't know if I could successfully get through that whole point. Maybe. Okay. What would I have to do with the next one? Again, I have no rule for multiplication, so I can't just take the derivative of each piece. It is x to the negative 2 plus 1 times x cubed minus 7. As it sits. Yeah, multiply together. FOIL. Or if you haven't slowed up, FOIL. So f of x would be x to the negative 2 times x cubed. How do you do that? Add the exponents, so you just get x. Outer, I would get negative 7x to the negative 2. Inner, I would get x cubed. And last, I would get minus 7. So f prime of x would be, well, what's the derivative of x?
1.
1. What's the derivative of negative 7x to the negative 2?
Plus 14x.
To the negative 3. Remember, subtract 1, and so negatives work weird. They end up going farther than negative, right?
3.
And then where's the 7 go? 0.
Where'd you get the one again?
The derivative of x.
So it's not. Oh yeah. Okay.
The derivative of a linear term is always a constant. Okay, the others are more exponent property problems. I'm going to rewrite this next one. See it. These are the hardest power rule problems I can come up with. This is it. This is as hard as I can make it as far as power rule goes. Uh-oh. What are we going to do on this? We need to use pre-calculus skills. Okay, the negative 1 exponent, what does that do to a fraction? It flips it. So I'm going to do that. I'm going to flip it. Which actually is really nice because with it flipped, what can I do with it flipped? That I couldn't do the other. I can divide both pieces by 4x cubed. I actually couldn't do that the other way, so it's nice that it flipped it. It probably wouldn't be on a power rule problem if it didn't work that way. So this is 3/4. No, yeah. I'm saying it right, but I'm not right. 3/4 x. Are y'all okay with where we got the 3/4 x? X to the 4th divided by x cubed is just x. Minus what? You tell me. Where is the x squared? So what's that mean? Would you agree those are equivalent? And now the power rule is easy. So, the hard part of this is the pre-calc part. 3/4, remembering your properties of exponents. My plus x to the negative 3. And if you wanted to rewrite that, you could. 3/4 plus 1/x cubed, and you could make that back into a fraction if you wanted to. But moral of the story, it's a lot easier to say. Okay, one more. X to the negative 1 minus x to the negative 3, all divided by x to the negative 2. So, how can I simplify that using pre-calc? I'm going to rewrite it like this first. Divide both pieces by x to the negative 2. And again, I want to say this one more time. What's the property when you divide two things with the same base with exponents? What do you do? Subtract the x. What is negative 1 minus negative 2? Negative 1 minus negative 2, which is plus 2. Negative 3 minus negative 2. So what's the derivative? Don't forget to subtract. Don't add, subtract. Pretty nifty rule, right? Again, squared plus 2. Okay. It says find, sketch the horizontal tangents. What in the world is a horizontal tangent? Okay. Then it says find them. Well, I might could guess, but where would the horizontal tangents occur? Drew them into the max. That's going to be big news later. Where would they occur as far as the derivative goes? Close. And the derivative is 0. Horizontal, so vertical. So could I find that derivative in a few seconds? So horizontal tangents occur when the derivative is 0. So I want to use calculus to find this. Everyone agree the derivative is Can I find when that is 0? Solve that equation. Well, the factoring, what factors out of 4x? So what is x? Good, x plus 2 and minus 2. 0, 2, and negative 2? Go back and look at that picture. Did we seriously find the maxes and mins on a 4th degree polynomial without a calculator? How long did that take us?
2 minutes.
What's the equation?
X to the 4 minus 8x squared plus 2. So you can see that this has opened up a whole new world of what we can do in a very timely manner. It's pretty cool. Higher order derivatives is the last thing we're going to talk about today. Yesterday it was so hard to find a derivative. You sure wouldn't want to do it again. Right? Because it took so long to do it. Now, could you envision taking derivatives as many times as you wanted? You could take derivative and then do it again if you felt like it. For whatever reason, we would feel like doing a derivative twice. Those are called higher order derivatives. So the derivative of the derivative is called a higher order derivative. It's the second derivative. It doesn't seem real important to you yet, but so the second derivative is denoted by 2 tick marks. We're going to say that f double prime or the second derivative of f. Either way works. If I put 3 tick marks on it, you can envision that that's the second derivative, and we'll take the derivative 3 times. After 3, they stop using the 3 tick mark notation. They go to a 4 in parentheses or a 6. This one's 6. Now what I do want you to do is I want you to write down all 5 of those. But there's 5 different notations for the exact same thing. You need to know or be aware of them all because you'll see them occasionally pop up in different problems. There's 5 different, so the biggest thing on this slide that you need to write down is this 5 things down here. And note at the side, these all mean the 6th derivative. Those all have 6's on them. They all mean the 6th derivative.
So after the third, that's right.
Right after the third, they just, up until 3, they do tick marks. Actually, though, in Leibniz notation, and this one over here, that even on 2 and 3, they write this. They do the d2y dx. Later, as we get more into derivatives, we'll talk a little bit more about those notations and what those mean. dy dx equals either way. I'm going to call it f prime. 9x squared minus 4. That's the first derivative. What do you think the second derivative is? And the third derivative? And the fourth derivative? And any derivative after this. Okay. That is hyperorder derivatives. Again, right now you're going, okay, that's fun. I don't know why I do it. We will talk about how you would do that in real world context later. Right now, just see your thing. The next one, is it ever, it's x to the negative 2, by the way. Is it ever just going to go away? No. Because we'll just keep getting farther negative exponents. I'll call this one y prime. Negative 2x to the negative 3 minus 2. 500 does go away. The second derivative is 6x to the negative 4. Am I going too fast? You're good for the last slide. Third derivative. Fourth derivative. Gotta do a little clock on multiplication. 120. 72. Negative 720 x to the negative. So that's how you do higher order derivatives. You just keep doing the power rule over and over. Big thing to take away from homework. Remember, this only works if you have a function that appears to be like polynomial. Of course, it can have negative exponents or fraction exponents. But anything multiplied together or anything divided, you're going to have to fix it first. Now, everything on your homework tonight can be fixed, can be turned into one of these power rule problems. And make sure you don't just take derivatives as pieces if they're divided or multiplied. Get it in that format first. Any questions?
Yeah. I'll just look at it on the back first.
Yes. If it says if the question says, everyone listen to this, and I'll go back to a problem. If the question says f prime of 2, then you take f prime, after you find it first, and then plug in 2. So just like you would have done yesterday when you found the derivative of the long way, find it. So if it says f prime of 2, just find the derivative and plug in 2. You remember how we found tangent lines? Did you do that a lot faster now? Which will actually spend your time on that later. You have to find the first one. You do unless you notice something like on this one, because it was a third degree, you could probably skip to the fifth derivative easily. How is it? Right, you're going to have to. There's no way to skip. Most of the time, the AP exam is going to stop at 2 or 3. Those are the most useful in the real world. Does that make sense? Told you you would have to do it like that.